So this should have been a review of the things we've been doing for the past couple of days. So for the first one, you should have solved it just like we have been. Combine like terms, get all the variables on one side. Here I got 9/5. Did everyone else get that same one? Or 1.8 would have been the decimal. Yeah. And then you could have done this a couple different ways. So I just used fractions, but you could have used decimals. You could have used like 1.8 and then whole numbers. How you did this number line is, there's a bunch of different ways you could have done it, so it didn't have to match mine. I just used fractions because it was easy for me to count that way. But this would be a closed circle at 9/5 or 1.8 going to the right. Do you have any questions on that one? Number 2, you also needed to solve, and you ended up with another fraction, -1/2. And again, when you did your number line, you could have done this a couple different ways. Use decimals, fractions, whole numbers, a mixture of those. I think I used a mixture. So this would be an open circle at -1/2 going to the right. Have any questions on that one? Number 3, you needed to solve it and then figure out which one of these numbers from the solution set were actually in the solution set. So after you solved it, you should have gotten x is greater than 1/3. And then you just have to find which of these numbers would be greater than 1/3. 1/3 wouldn't work because it's not greater than or equal to. If it said greater than or equal to, then 1/3 would be an answer. 1 and 2.5 would work because those are both greater than 1/3. And then you could really make whatever number line you want. I counted by 1/3. Counted by thirds, anyway. And 1 would be greater, and 2.5 would also be greater. So those two would be part of the solution. I don't think I mentioned this yesterday or Monday, but really when we find these inequalities, like when we were solving equations, we were finding one solution. Here we're finding a bunch. There are many solutions that could be in this set. Everything greater than 1/3 could be a solution for this inequality. So if we were to test this, there are a bunch of possibilities we can put in. The last one, as we start solving it, what happens is our variables disappear. In a normal equation, we would get some specific answer like no solution, infinitely many solution. Or we would think the solution set is like 0 no solution. In this case, because of the inequality, we're really just looking to see, is this a true statement, is it a false statement? So when we get down to the end, and there's nothing left but 0 is greater than 15, well, that's not true. So my answer for that would be it's false. I've solved this, and this is false. It's not really no solution. No solution isn't in the solution set. It's just this is false. Any questions on any of those 4? Everyone should have the next set of notes on their desk. This part is a little, it's mostly new, but with some of the stuff we learned in the past couple of days. So today we're going to be talking about compound inequalities. So make sure you have those notes in front of you. If your phones are distracting you, put them away. So to start off, compound inequalities are two inequalities or more joined together with an and or an or. So when we talk about compound inequalities, there'll be two different types, and you'll need to know, is this an and inequality or an or inequality? The first one we're going to talk about is or inequality. Anyone still need this part? Or inequalities have a tendency to graph apart. And you'll see what I mean by that here in a second. So in this example, let's say we got some inequality, they solved it, and they got these two things. X is less than or equal to -2, or X is greater than 3. We would graph both of those things on our number line. So X is greater than -2 would be a closed circle to the left. X is greater than 3 would be an open circle to the right. They have a tendency to graph apart. There are two different arrows on the same number line. And how we would write that interval notation is we're still reading left to right. So from left to right, this starts at -infinity because it keeps going. And then it stops at -2, and -2 is included, so we would use a square bracket. Because these are or inequalities, I would say or. It would start at 3, but it's open, so parentheses. And it goes to positive infinity. So when we write these answers, and I meant to say this before as well, if you feel confident and comfortable with the interval notation, you can use that. Not on this, do both on this, but when it comes to like the quiz, the review, the test, you can write the interval notation, or you can write this set builder notation, this solution set. Either or if you want to write both, that's fine as well. So when we solve these, you're going to get what looks like two separate inequalities. You're going to solve both of them separately. So pretend like this was an inequality, and then this was one, and you're solving them separately. So this first one, I would add 4 to the other side. The second one, I would divide both sides by 2. So I'm not doing the exact same thing to both sides because these are two separate inequalities. once you have your x by itself with your inequality, this would be your solution set, and you can graph those and do the interval notation. So x is less than -3 would be an open circle pointing to the left. X is greater than or equal to 6 would be a closed circle to the right. The right side inequality doesn't always go to the right. Sometimes it'll go to the left if we happen to switch signs or something like that. Same thing with the left. It won't always go to the left. Sometimes it'll go to the right. So don't assume that. And then when we write this interval notation, it's going to start at -infinity. It's going to stop at -3, but it's not included, so we need a parenthesis. And then or it's going to start again at 6, but that's included, so square bracket, and go all the way to infinity. Do you have any questions, concerns, confusion on how we solved that or got those answers? What's nice about compound inequalities is that these are simpler inequalities to solve. It's not like you have to distribute a bunch and then solve. They're usually more on the simpler side. So let's do number 3. Again, remember that you are solving these separately. So if you want to completely solve one and then completely solve the other, that's fine. So for number 3, I'm going to start with the 2x plus 9 is greater than 17. We're going to subtract 9 on both sides. And then divide both sides by 2. And then I'm going to solve the second one. Subtract 10 on both sides. And divide both sides by 5. So now I have x is greater than 4 and x is less than 0. That would be my solution set. And I could graph both. X is greater than 4 would be an open circle going to the right. X is less than 0 would be an open circle and open circle going to the left. So this is a good example of the left inequality doesn't always go to the left. And then my interval notation for that one would be -infinity to 0, both with parentheses, or 4 to infinity, both with parentheses. Have any questions so far? Is this making sense so far? Yes, yes. We'll do one more together and then I'll let you practice them, and then tomorrow we'll focus more on the ands. So we'll do number 5. Again, solve each one separately. So the one on the left, I would need to either distribute or divide by -3 on both sides, since 15, since 3 goes into 15. But I'm going to distribute. And then add 3 to both sides. And divide both sides by -6. Remember your inequality rule. If you multiply or divide by a negative, you have to change the sign, the direction of the sign. So this would become greater than 2. And then you could solve the other one. Subtract 1 on both sides. And divide both sides by -1. The sign is going to change directions because we're dividing by a negative. So x is greater than 2, or x is less than or equal to -4. Would be our solution set. What's nice about these is because you know that they should graph apart. If something happens and they're graphing towards each other, and it was supposed to be an or inequality, something's off. Now when we get to and, that's supposed to happen, but we'll cross that bridge tomorrow. So x is greater than 2 would be an open circle to the right. X less than -4 would be a closed circle to the left. And then the integral notation would be -infinity to -4. But -4 is included. And then 2 to infinity, where 2 is not included. Questions about that one? For the remainder of class, I want you to try the last 2, 2 and 4. I'll be walking around if you have any questions. Let me write it up. Did you have this time to work?